All right, let's jump into it. So this talk is basically just an overview of software testing and some practical applications. There's a mix of some information about like theory-esque type of things, like what things to do for testing. But for the most part, it's just kind of a case study of a bunch of different test things that I've worked with. So that's kind of the core summary of it all. So first off, why should you write tests, right? Most important thing. Popular reasons are it helps verify that your code is correct. Obviously it does, so guarantees about that are good. You know the software is working as intended. And that it makes development easier, right? It's easier to kind of iterate on things. If you have test cases, you can do that type of stuff and like break contagious. These are definitely correct. So yeah, definitely when you're working with groups. But here's what I would say are some like better reasons per se. It self-documents behavior, right? A huge one. It forces you to consider edge cases. So things that you might not normally think about in your code, you will write tests because when you're writing those tests, you'll think about all the possible data that can be sent functions or whatever other parts of your program, and you'll be able to handle that much better as a result. And the other thing is that it ensures code that you depend on continues to function as expected, right? Your tests are not just testing your code, they're testing kind of everything down the stack. So if you use a dependency or a library, that makes sure that any updates that you make to that dependency are going to be reflected in your tests, and so you make sure that all continues to work as intended. So yeah, libraries, environments, other things like that. So this is a quick example. If anyone's ever run npx create react app, these are all the kind of dependencies that you deal with. npm, react, I went with these all, JSON stuff, jest, webpack. And the little gimmick here I have is, call me maybe, right? Just as you have all of these dependencies in your project, a good system will only include the code that you use, but nonetheless, they're there and can be accessed. And you may or may not actually be calling these dependencies. It's still a liability that you have to deal with in that code base. It is a risk to any type of long-term maintainability or accuracy of the code. So you can see down there, I have an image of just standard create react app. You'll notice that this package lock has 15,000 lines. JSON is not the most condensed format, but nonetheless, 15,000 is a little bit absurd for effectively a basic React app. Fun fact, I learned yesterday that Create React app is now deprecated. So interesting. Unit versus integration tests. The most heated debate since tabs versus spaces. Yes. So what is unit tests? Unit tests cover single components, some type of single thing in the software. They're very easy to reason and think about in general because you're generally only testing one single thing. So you generally have like inputs, outputs, whatever else. Your integration tests are going to cover larger systems. There's no clear definition on like what counts as that, but you're generally going to be more focused on business processes. So your integration test is kind of saying if a customer or something in the application happens, you do this, then it does this kind of process step by step and involves multiple components, and the end result has this effect on the end business. So that's kind of something closer to when the user calls this API, it does X, Y, Z. These things all get updated. It calls this external service. The response is processed, and then you're kind of done. It's more likely to involve shared state as well. And it's just a natural consequence of it being about these larger systems and those business processes. It's generally going to be causing some type of state change that you need to consider. So what do you prefer? Well, it comes down to situations. But I would say unit tests when the behavior should be stable. So it's very clear what should happen, and that's not expected to change frequently, as well as when edge cases matter. If you have to be more precise with your tests, unit tests are the better way to do that. The greedy approach falls flat when you're dealing with things like this. And so this basically means that if you try to just kind of accumulate a bunch of tests, you're not going to be able to that very well. You don't know what edge cases you will or will not cover, so that's a problem. Otherwise, do integration tests, right? Integration tests are helpful for things like that. The majority of tests will probably be unit tests, but integration tests are very good to have as well, and they're more stable long term because they represent business processes as opposed to particular code things. So, on to our first case study. This is Rhovas, for you if you were at my talk earlier. This is the programming language I'm building. Lines as of last night, 7,249 lines of source code to implement the actual language. And there are 7,559 lines of tests. So 953 total tests. And so the end result here is that obviously there's more test code than there is actually source code. Part of this is just because the nature of test code is you will have a lot of duplication for simple reasons of you're setting up test states or you're defining input and output and other things like that. But nonetheless, there is a significant amount of tests for a relatively small amount of code, and that's because the complexity of code can be very condensed in terms of number of lines, and they still have a lot of cases you need to cover. So I make changes to the language all the time, and what was happening very early on is that without these types of test cases, it was very difficult to tell if I could make large-scale changes to the language. And so having all of these tests and very strong coverage over this, almost perfect code coverage, was one of the main ways I was able to redesign large sections of the language to implement new functionality and be confident that I wasn't breaking anything that I would eventually discover and have to go back and fix. That said, I've now kind of migrated more toward integration tests because the new version of Rhovas supports both JVM, like Java, as well as JavaScript for running things on the web. And so I don't have something in place that can run unit tests on those very well. So the idea was to go more integration tests, write programs, and then those programs could just be evaluated in turn on both JavaScript and JVM. The other thing I'll note about the unit test too is that I have unit tests for each particular stage, and that helps me know exactly what stage went wrong without digging much farther into things. If I have an integration test and it fails, I have to look very carefully at the error message to find exactly what went wrong. And so unit tests are good for that too. Next topic here is test-driven development. This is kind of one of the keywords that I really don't like, personally speaking. I find it can be helpful for a lot of people, but I also find that people tend to run with TDD and like go a little off the rails with it, and it kind of causes problems with the tests that they write. We'll see why in a second. So the main definition of test-driven development, is from Uncle Bob Martin, is 1, you write tests before code. 2, you write only enough tests to fail. And then 3, you write only enough code to pass. And so the idea is you go on a cycle of you write tests, then you write code, then you write tests, then you write code. Right? And of course, you repeat and refactor. Right? So as you go through, you keep going, and then you improve the code. I mentioned the refactor piece here specifically because that's one of the many flaws that isn't as explicitly called out in other things. But the idea is that as you write that software and it gets more complex, you need to redesign your implementation a bit to work a bit better for the situation you're currently handling. So things that are not addressed. What guarantees an optimal solution? Right? And so this has the same problem as the unit test that I mentioned previously, which is that the greedy approach falls flat. Right? If you try to build up an implementation one small component at a time without considering the large problem, there's no guarantee that you'll ever get to an optimal solution, let alone you're dependent on what edge cases that you happen to think about. I think that's my next point. Yeah, how do you know that you've actually tested everything? Right? If you don't have a clear understanding of what you're testing, then all of your test cases just kind of exist in the void, basically. And so this is things like code coverage, right? It helps, but it isn't everything. So there's an alternative idea called design by contract. And this is basically saying that instead of just kind of writing tests in the void, the first step of that process should really be to define what your code is trying to do and to think about as many edge cases as you can. Right? That's really just to kind of get a good idea of the problem statement overall and then build up from there. So a contract is basically a specification of a function that includes preconditions, so which have to be met by whatever calls that function, and post-conditions, which are ensured by the implementation. Effectively, we call this API, right, the interface for that function. And so, for example, I have this square root number, right? We've kind of seen this example, so we kind of know where this is going earlier. But, I pass 16 in, I get 4 back, basically root. If I pass like any type of x squared in, then I expect to get x back. Right? Obviously, if we throw in decimals or like weird, other computer science math specifics, this gets a little bit more wishy-washy, but mathematically. So this is, that point, right? If I throw in 7, what do I get? I get something close to the square root of 7, but because of computers, it won't be exactly. So one of the things there is you might want to think about how precise are we actually talking about, right? Is it the closest possible number, or is it good enough to, 3 decimal points, 10 decimal points, right? And depending on the application, you may need more or less precision, right? Game development, for instance, is very common for being very wishy-washy on the precision because there's a lot of cases where it really just doesn't matter too much, right? If the player is, 0.0001 places farther left than they should be, no one's going to notice that. Now, what happens if you throw -7? 2.6i, right? Complex numbers, maybe most languages won't have this, so generally you see something like an error. But that error is part of the thing where you probably want to test, right? So if you're building a standard library to implement a basic function like this, you probably want to have a test that covers what happens if I give it a negative number, right? And part of that just falls back onto defining what happens in that case, so it's very clear to anyone who might run into it. So you can define a precondition of this, which is like require the numbers greater than or equal to 0. There's other weird things you can talk about, like -0, which is a thing that exists. Infinity, not a number, which is everyone's favorite thing. And then your post conditions are ensure that the result is effectively the actual square root of the original number, which is to some accuracy or precision or whatever you're looking at. And so, that would look something like this, and it just kind of overflows off the screen. So another case study. So I built a little project called Magnetar. We use this for a class called PLC, or Programming Language Concepts, when I was a teaching assistant for it at UF. I helped design the curriculum, and I did a bunch of work on building the automated test suite that we used. The way the class was run is that each student had basically just a giant list of kind of specifications, and then we had a series of test cases where the end goal was they would get feedback on whether they implemented the specification correctly or not, and then based on that feedback they had an opportunity to revise their code and then resubmit it before ever actually being finally graded on it. And then at the end of the semester they could resubmit everything for the entire project and have another grading opportunity for it again. And the main reason was UF did not really have a class that dealt with this type of specification work, which is super important for developers to know. And so this was kind of the class that we decided to design for to fill in that gap. So in total, there were 17 assignments, 17 different submissions. This is basically, there were 4 assignments with multiple submissions for each, which is how you get to 17 here. Almost 120 individual groups of projects that were submitting things. Over 1,000 tests in total throughout all the different assignments. And we had to get results back to them within 1 day, right? That's what we wanted. We wanted a very fast turnaround so they could get that feedback and then have 2 or 3 days to prepare for the next submission, right? And so we built this library that went through everything, and we wanted to auto-grade it all. And part of what was really important about auto-grading that was we had to have a clear specification for them. Right? Without a clear specification of what the intended behavior was, we had no ability to do any type of auto-grading or anything like that. It just wouldn't be fair. Right? So we had to make it blatantly clear what should happen in every single case, and any type of questions of behavior always went back to the specification that they were provided with originally. And that's what enabled something like this to work so well. So generally, some tips for tests. Before writing, have a clear contract to test. As mentioned, helps a lot. You want to set up an isolated environment, so minimize any type of external dependencies that you're relying on. For instance, at my current work, we had a thing that would basically record web requests that were made and save those in order to be rerun later. That is great because at the very least we're not making live web requests, but it's still very sketchy in the sense of we really don't have good control over what external services are being accessed or what type of things are going on in the network. So it's much better than doing it live, but it's still pretty unstable. Don't rely on shared test data. It's definitely a huge one. Tests that might mutate that can throw things off. This is something common you see in JavaScript, where someone will define a shared test object, pass that into a function, it'll get mutated, and other tests will start failing later on. And that's one of the ways you would get flaky tests. And then use mocks only when needed. Right? We'll talk more a little bit about mocks later. When writing tests, test one logical unit at a time. Right? Focus on one piece, build things up, and go from there. Follow something called a range act assert. This is a very common thing where you basically do all your setup code, you do whatever action you have, and then you do all your final assertions. It's a very standard pattern. It's good to stick to this up until you're comfortable enough to know when to kind of break it. Test helpers can be very useful for this. I am a fan of basically defining helper functions to do setup, even if it's like more complex than any single test needs. I find that doing the test setup individually per test in general makes it much less clear what's happening or what the small differences are. So I'll build like a test setup function that takes some arguments, and the test will call that setup function with whatever arguments they need to. It's similar to parameterized tests, or parameterized tests, which are also a good thing to use as well. And then use descriptive, not dummy values. So the example I have here is username, not Alice. One of the things that you'll see is that he will kind of throw in, fun things, and it's good to have, some fun with tests and stuff, but it can definitely make the error messages less clear when they do occur. So for this is to use like very simple descriptive values for what things are. That way it's very clear what they're supposed to represent and where they came from when you do see those errors. Similarly for like integer numbers, or just number general, pick simple things, 0, 1, whatever else. And then if you need numbers that actually have meaning, then start picking them. For example, if I'm going through my test code and I see the number like 42 somewhere, right, I'm guessing that's probably like a joke inserted in by one of the developers. But if I see like other weird numbers, I'm going to start thinking that those have some significant meaning to the test specifically, right? And if that's not the case, then my attention is drawn elsewhere from where it needs to be. So if I see very simple numbers like 0 and 1, I'm assuming it really doesn't mean much. So it's helpful for identifying what is actually being tested. So another case study, I worked on a bunch of Minecraft plugins. One of these is called FlashLibs, and then another one is called CrateCrate, which is the stupidest name for a plugin ever. I'm so proud of it. But basically it does like loot crates if you've seen it in different video games and stuff. The thing that's unique about this being Minecraft is that you really can't do any type of like easy unit testing or really almost any automated testing because there's such a complex environment for Minecraft stuff, and to trigger events you need players and entities and all kinds of other things where there's so many factors. It is very hard to replicate situations easily. It's much more easier to manually test stuff, and so most of this did come down to manual testing. However, there were a few key things. FlashLibs, for instance, is like mainly library stuff. So for some of the library things, I tested kind of the core components to make sure that those main pieces worked, and then kind of relied on manual testing to verify the in-game behavior. But then for crates, there was like one particular piece, which was the config management. So users get like a text file that they can edit, and then that text file has very complex rules to define how it actually gets turned into something that they can like, click on and open and get like, an item or money or whatever else from. And so that was huge to basically build a contract for. So the plugin has full Java docs for every single one of those parsing methods, as well as most other things too. But those parsing methods in particular cover every possible case of input that's relevant and specifies what should happen in that exact case. Because that was the only way that like on a project of one, that was the only way that I could keep track of what was actually supposed to happen in these cases and make sure it was doing the right thing. So that documentation there was essential. And so as mentioned here, this is used previous version by like over 30 open source projects. So it's relatively well spread for still being a plugin, and then full Java docs as mentioned. All right, last main kind of topic is mocking. You can't jest without mocks. See, it's a pun. So when should you mock things? For a quick recap, mocking is basically replacing the implementation of something with a test-specific implementation. Normally you do this to like bypass something like a network recall, or set up simple data that should happen in a situation, so it's not doing like other crazy stuff in the test that could complicate things, like making it more reproducible for the test. So when should you mock? When behavior is not in your control. The examples here are things like dependencies. Obviously, very simple libraries you should never mock because you want to make sure that dependency is doing the right thing. But if you're doing network actions that go across the web, even if it is in your control, those network things can still fail. So you never want to do any of that networking stuff because it's not reliable. But even then, whatever service you're calling could always be updated too. In more advanced applications, we are dealing with like these whole multi-tier things like is popular now with microservices. You could run into situations where your tests just so happen to be run as like one service is trying to be updated and the other one is, and now you have different versions trying to communicate with each other, and it would just be an absolute nightmare to debug. Thankfully, I've never run into that one myself. And then also when necessary for reasons. I put an asterisk here because it varies by case, right? And that's something that just kind of comes with experience of knowing, yes, this is a situation where using mocks are justified, but they're definitely not the first tool to reach for. So how do you mock? Mock the smallest surface area possible, right? If you're mocking network requests, try to mock it to the specific route that you want to test, right? Or even to some extent the different data that you want to be sending. That's obviously helpful. There's a balance trade-off that's going on there, right? Sometimes it can be very difficult to like assert that you're calling an external service with the exact API things that you want. Likewise, that makes the test a little less stable as that service interface changes. And then this includes which tests have mocks. So it can be common to set up like one mock that's shared by a bunch of tests. Another alternative is to set up mocks specifically for each and every individual test. I don't have a strong preference on which. I think it varies on a case-by-case basis. But in general, if you try to mock too much, you start getting into a point where you're not confident whether your mock's being used or not. And so that gets into this point, which is that you want to either ensure that your mocks are actually being used and called, or the result depends on the usage of that mock. Right? So if I mock a function to return some test data, obviously if it needs the test data to pass the assertion, I don't have to worry about whether the mock is called or not, because if it wasn't, then the test would fail. But for some other things, like if I just make an API endpoint to log things or do like a post request to, I need to make sure that that mock for the post request is called. Otherwise, I'm not really testing that behavior. So one last case study. This is a little bit more advanced one, but round things out here. So when I was an intern at Infotech, we built this release notes app. This is a public app, still available and stuff, though it's changed a little bit since then. They actually made it easier to solve the problem that I'm talking about, which is great because someone finally found the code and was like, why did we do it this way? And hopefully the answer was because we were told to, and we said that's not a good way to do it, but we still did it. So not all over that. But anyways, someone finally improved it, so very good. But this was over 6 weeks, so that was not the whole internship, but a chunk of things we did. And we had about 100% test coverage, best test coverage to our ability, simply because there were other things and we spent a lot of time on that. So this is roughly what it looked like. We're going to get into some Microsoft Paint diagrams, so bear with me. Basically what would happen is that you would display a bunch of release notes for services per year. You had some filters on the right for different years, products, tags, whatever. Those aren't too important. The main thing is that it was done by year. So you can see we have 2022, and then a load more button, and when we would load more, we would get to 2021. And so it would kind of chunk these up at different options, and if there were too many in a year, it would kind of chunk some of that up as well. Now, this is kind of roughly what that looked like. So what effectively had to happen is we needed to start by figuring out what the earliest year was. Because, for instance, if it just turned January and there's no posts in that year, you would click the load button, like nothing would show, and then you would have to click the load button. So we didn't want that. We wanted to make sure that whatever was shown was definitely like a post visible. So we had to first start by getting the first year, right? And everyone might be saying, like, just use pagination. Yes, but custom behavior, right? It didn't, like this, the content management system we're using didn't support this behavior, which is why we were like, no, we should just do normal pagination. And thoughts on that have already been shared. Anyways, so we had to get the first year, then we had to get that post for whatever the current year was, which you could send off very easily together. And then for loading more, we would basically get the post and then update the year. So we would keep going back year by year by year by year like that. And this kind of allowed us to basically do that by year set of filtering. And so that kind of looks something like this, right? You click load more, and then it would have to go year by year by year in case ones were missing to get back to 2018. Now, obviously, there's probably not going to be a gap of 3 years between release notes, hopefully. But, for sake of, good software design and learning experience and whatnot, we wanted to make sure that we covered every one of these edge cases we could think of because we thought it would be a good learning experience. And so this is kind of what happened. And then at the very end, here you can see this end. And so this is kind of what it looked like in order to get this logic to work. It's not as simple as that previous diagram because effectively we had to deal with prefetching data so that things were responsive enough. There was different things depending on whether the first year was available or not because we had to wait for that API request to finish before we could start getting other years. Because otherwise we would just keep going and going and going and going and we would just like get to like 10,000 BC before like the person would finally exit the page because they thought it was broken. Not to mention we'd absolutely kill network stuff everywhere. All of those can, of course, fail, so you have error states you have to deal with. Then you have to deal with what happens and like continue this prefetching behavior. It was confusing. So we had multiple attempts to try to kind of break this all out and stuff, but it didn't really work well. And so the solution was to actually build a state diagram for all of our possible states and what state this whole loading process could be in. And then based on these states and the possible transformations, we built a series of test case that covered every state transformation that we knew about. And through those test cases for each state transformation, we were able to make sure that the logic we had in that code was accurate so it did the right thing on that particular behavior. And this is what gave us the confidence to say, even though we had this really complex behavior that we probably shouldn't have done, but we did, and even though that was so complex, we were able to say, yes, with certainty, this does the right thing in as many situations as we could possibly think of. So with that, I will leave it up to questions. So if you have any quick questions, feel free. I think we've got 3 or 4 minutes.
What testing framework did you use for it?
This was Jest, so it was Site. So we used Jest for it, yeah.
If you have, like, for example, if I have an external API that I need to call, you say that's a dependency, we should mock it, right?
Yeah, so just repeat the question for recording. So if we have an external dependency, we should try to mock it. Yeah, so like all of our network requests, we mocked that network request where it returned the expected chunk of release notes for that because we're trying to test the front end and stuff. It is also helpful to have options for like the full integration tests where we can hopefully run it against a live or semi-development server so we make sure that the API interface between those is accurate. So good to have a mix of all the things. But for like the really detailed state diagram stuff, you need kind of unit tests in order to really handle that. Yeah?
Can you talk a little bit about like just conceptually what edge cases are and like what's the thought process you go through in trying to figure out like what are good edge cases that would be to test for?
Sure. So talk about what edge cases are and just how do you identify them. So edge cases are effectively situations where specific values, right? So like integers are huge, right? There's 2, 4 million of them, maybe more depending on what size you're using. But there are many of them, way more than you ever could possibly want to think about. However, some of them have important meaning. For instance, I might have an if statement that says, if the number equals 0, do something different, right? Or if the number is negative, do something different, right? And so the end result is looking at edge cases is primarily going through, so the technical term is called white box testing. You have black box testing and white box testing. And that just depends on whether you're kind of treating the implementation as something you know or don't know. What I find is that treating the implementation as something you know for identifying good test cases, but never rely on the implementation as best as you can. But so for instance, like if the number is 0, you want to make sure that you include a test case that has that number being 0, right? Combinations. Another example might be if I have a list of 0 elements, 1 element, and multiple elements is always going to have various different edge cases around it, right? It's very common to run into problems with those. 0 elements, you can obviously just try to get something and it's not there. 1 element is generally when you're trying to render things between items. So like if I render a list and I want spacing between the list, if it's just 1 element, that might do something weird. And then multiple items for just generally testing the main behavior. So those are kind of like the key edge cases and like how you might identify those. It's just kind of identifying patterns both in the types of values you're using, like for lists, 0, 1, multiple. Simple enough, I normally use 3 just to avoid any maybe weirdities with 2, but 3 is generally good. And then looking at the implementation to find particular values that might be interesting and worth testing. Does that make sense?
Yeah.
Cool. We have time for, Never mind. We are at 2:16. I will end it there. Thank you very much. If you have any other questions, feel free to cut me out in the hall. So thanks all.